So first we graph these two curves to see what is the intersection between them and what are the region that we are looking at. So here, so first of all, you have your x-axis, then you have your y-axis here, and then the decreasing line, this is y equals to negative x. And then for the other one, you have y squared, which is 2 minus x. So since you have power 2, y becomes plus minus square root of 2 minus x. So for the positive part of square root, you have this portion. And for the negative portion, you have down here. So that's how you get a hyperbola. On top, you have y equals to positive 2 minus x. And down here, you have y equals to negative square root of 2 minus x. So the portion that we try to find the integral is this portion. But is it easier to take the integral with respect to x, or is it easier to take the integral with respect to y? If you decide to take the integral with respect to x, this is what's happening. With respect to x, you have to divide this up into different portions. With respect to x, you have one portion on the left side, and then you have another portion on the right side. Why is that? Because the ceiling and the floor are different in these two portions. The ceiling on this portion is square root of 2 minus x, and the floor or the smaller y value is this decreasing line. Well, to calculate this integral, you're going to set these two equal to each other. So x plus y squared is equal to 2. Let me write down 2 first, then set them equal to each other. And then you have x equals to negative y. So wherever you see x, you're going to plug in negative y, you get negative y plus y squared equals to 2, or y squared minus y minus 2 is equal to 2, y minus 2, if you factor it out, y plus 1 is 0, so y is 2, and y is negative 1. So when y is negative 1, your x is negative y, so x becomes 1. When y is 2, your x becomes negative 2. So at these 2 points, at negative 2 and at 1, you find this area. So this area, let me write it with a different color, is the integral negative 2 to 1. The ceiling is square root of 2 minus x, and down here the floor or the smaller y value is negative x, so minus x. Then you take the integral with respect to x. Then to find the second portion, it is the integral. So let me write this guy down. I'm using this part, this portion, plus the integral between 1 to 2. 1 to 2. The top function, as you can see here, is y equals to 2 minus square root of 2 minus x. And down here, you have a negative sign in front of y. This is this function. So you have square root of 2 minus x minus square root of 2 minus x dx. But instead of calculating the integral with respect to x, we prefer to calculate the integral with respect to y because it is much more easier. So let me erase this portion. . I'm going to calculate the integral with respect to y instead. With respect to y, it makes the calculation much more easier. Why is that? If you just flip this and look at the visualization, this is your x-axis and this is your y-axis. Just rotate this 90 degrees. So you can see here I have this guy down here, and then this object, this line, just passing through this way. Now here you have x, which is 2 minus y squared, and down here your x is equal to negative y, and your y is bounded between -1 and 2. So the integral, the area is -1 to 2. The larger x value is 2 minus y squared. The smaller x value is negative y. Then you take the integral with respect to y. And this guy in turns is equal to the definite integral -1 to 2 of 2 minus y squared plus y dy, which in turns can be written as, so let me erase this portion. We don't need these. This is equal to 2y minus y cubed divided by 3 plus y squared divided by 2, as your y ranges between -1 to 2. So plug in 2, you get 4 minus 8/3 plus 4 divided by 2 minus, now plug in -1, you get -2 plus 1/3 plus 1/2, and the rest is pure algebra. You get 6. So you get 6 minus 8/3 minus -2 plus 5/6, which is equal to 6 minus 8/3 plus 2 minus 5/6, or you have 8. And if you take common denominator, 16 divided by 6 minus 5 divided by 6, or 8 minus 21/6, or 48 minus 21 divided by 6. And as we saw, it's equal to 9/2. So taking the integral with respect to x and then with respect to y. So the same area that we calculated, but with respect to x, we had to divide it up into 2 portions rather than 1 portion. But as you can see here, when you're taking the integral with respect to y, you just have the graph nicely, and you have a maximum x value, you have a minimum x value. The subtraction is easier. Calculating the integral with respect to y is much more easier and straightforward. So this is one of the main reasons that you're interested in converting these integrals into different variables. It's not necessarily always about taking the integral with respect to x. Sometimes it's important, or it's more convenient, to complete the integral and do the calculation with respect to variable y. And as I mentioned before, later on, we're going to introduce a new parameter like t or theta, and convert the integral into parametric form that help us to make the calculation much more easier.